Cisco instructor Andrea here, and today I'm going to continue my discussion about subnet masks. And we're going to talk about how we're going to use the subnet masks. We're going to look at the ones and zeros in the subnet masks and how we break those into the network bits and the host bits. And then also which one of those bits we use as the magic number or the subnetwork increment. The subnet mask is a set of continuous ones followed by continuous zeros, which we looked at in the first subnet mask video. The ones represent network bits, and the zeros represent host bits. So every IPv4 host address is associated with a subnet mask. The ones in the subnet mask tell the IPv4 address which network it belongs to. The zeros are all used to determine the unique host address. So a subnet mask can tell us a lot about the network. So the things that we're going to look at in this tutorial specifically is how to use the zeros in the subnet mask to determine the number of usable hosts in a network. We're going to look a little bit at the network bits and how we can use those network bits to determine the available networks. And then lastly, we're going to look at the magic number and how to determine the subnetwork increment. Now, we're not going to do very much with that other than just starting to look at it. We're going to use that in a later video. Okay, I'm going to use this table as an example to show you how to find the host bits with a subnet mask. I hope this little table looks familiar from one of our very first video tutorials. If you remember, the way that we arrived at this is 2 to the power of 0 equals 1, 2 to the power of 1 equals 2, 2 to the power of 2 equals 4. This is what I recommended you memorize. It's just doubling. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. And these are the subnet masks, and basically the number of bits in an IPv4 address as well. Now I'm only going up to a subnet mask of 16 instead of going all the way. In the actual class, when we talk about it, we'll go and we'll look at everything. Okay, so I'm going to do a couple of examples. Let's just start out with an easy example, and I'm going to actually put it to a network address too. So let's look at a network address of 192.168.0.0, and we're going to do a /24. So as we know that this is a subnet mask of 255.255.255.0. So we've got 192.168. 0, 0, and we have a 255. So we learned that the 24 tells us all of the consecutive ones, right? And the rest are going to be all zeros. So what's important about the subnet mask is all of these ones, these represent network bits. This is basically assigned to us from our provider, our ISP. These are all host bits, okay? The network bits, they don't change. They're going to stay the same. They're part of our network. So these are going to be the bits that are all in common for every device that's on that network. These are the bits that can change. These will be unique bits. Okay, so what we want to know is how many host addresses can we get with a /24 network. There's a couple of different ways for us to figure it out. Now, the reason I like this chart and the reason I want students to memorize it and or just get good at writing it down is because it's an easy way to figure out how many hosts are available with a 255.255.255.0 or again a /24. I can come right over here and I can see that a /24 network has 256 addresses, total addresses available. Now, if there's 256 addresses, I actually will subtract 2 from that because one address is going to be the network address. So that's the 192.168.0.0/24 address. And another address is going to be used for the broadcast address. And we're going to actually talk about the broadcast address in another video a little bit later. Every single network address has to have a broadcast address. Neither of these addresses can be assigned to a host device or an interface. So they are not usable addresses. So actually, this network has 254 usable addresses. Now, another way to figure this out is to look at the number of host bits. So, in a 32-bit address, I've got 32 bits because I have 8 bits in each octet. I know that 24 bits are all network bits. Network bits cannot be used for hosts. That leaves 8 bits for hosts. So I can also do the math. I can say 2 to the power of 8. Now 2 to the power of 8 is 256. Now again, if I did this little chart, I know that this was 2 raised to 0 equals 1, 2 raised to 1 equals 2, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7, 2 to the 8. Okay, so 2 to the 8th equals 256, and what do I need to do? I need to subtract 2. So I know that I have 254 usable addresses. Now basically what that works out to be is every combination of these zeros being turned off and on. So in other words, when I come up with every combination, that gives me every unique address. Now I won't be able to sit here and go through every one of these, but we know that every device on our network has to have a unique address. They cannot be the same, right? So that's essentially what this math does, is it tells us that 2 to the 8th, I could have 254 unique addresses. So you see, if I keep going, you can see how I can have just a bunch of different unique addresses, right? Without repeating myself. What does that look like? That's the first usable address, which we would use as our default gateway. Right? So here now I'm starting to, so can you see get the picture on how that's just replicating, and I can just keep doing this till I get all different combinations. Okay, let's do another one. So this time let's do a /19. Okay, so if I do a /19, I know that I need to turn on these first 8 bits. There's 8. I need to turn on the next 8 bits. So there's 16, 17, 18, 19. The rest of my subnet mask is turned off. So what would this be in decimal? My subnet mask in decimal would be 255, 255, 224. Oops, 224.0. Okay, so that's my /19. So how many usable host bits do I have? I have 8 host bits right here, 9, 10, 11, 12, 13. So I could do the math, right? So I could do 2 to the power of 13, which right off the top of my head, I don't know what that is. So what I'm going to do is let me go ahead and pull my chart back up here. Take a look. So a /19, that gives me 8,192 total addresses. Okay, so 8,192 total addresses. But what do I need to do? I need to subtract 2, because one of them is going to be used for the network, one of them is going to be used for the broadcast. So my usable addresses will be 8,190 usable addresses. Okay, let's do another one. So let's do 255, 255, 255, 240. Okay, so what is that going to be? I know all of these are on. All of these are on. All of these are on. And 240. Oops, that's off, 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 off. Okay, so how many network bits do I have? 8, 16, 24, 25, 26, 27, 28 network bits. So I have a /28. Okay, so I can do the math, which is 2 to the 4th. Now that math is a little bit easier. I know that 2 to the 4th equals 16. What do I need to do? I subtract 2, one for the network, one for the broadcast. So I'm going to have 14 usable host addresses. Okay, 14 usable host addresses. Okay, so in these examples, these are network bits. They cannot be changed. These are host bits. These are the bits used for making unique and individual host addresses. Over here, these are network bits. They don't change. These are the bits that all of the devices will share and have in common. These are the unique hosts. So this is a really small network. There's just going to be a few addresses on this network. So if you had a really small company, or maybe you had just your group of printers, say, on one network or something like that, you could put all of those devices on one little network and they would each have their own address. The next concept I want to talk about is something known as the magic number or the subnetwork increment. Now I just want to introduce this, and we're going to use it at a later time, but I want you to start practicing with it now so that when we use it, it will be easier and you will already be able to do it. So the magic number is basically the bit position value of wherever the last subnet mask bit is. Okay, so let me say that again. It's wherever the last subnet mask bit is. So in this example that we did, the subnet mask was 255.255.255. Here is the last subnet mask bit. Okay, so notice /24/24. So what I want you to see is that it's in the third octet, okay, and the positional value is that it is in the positional value of 1. So the magic number for a /24 is a 1. So magic number equals 1. All right, and that's also known as the subnetwork, the subnetwork increment, which equals 1. Okay, now the same will be true for a /16. So if you have a subnet mask of a /16, so here's a /16. The /16 positional value would be a 1. The magic number would be a 1. All right, so let's look at these others that we did. Okay, so the magic number or the subnetwork increment of a /19. So the /19 was 255.255.224. So what we want to do is we want to see where was the last subnet bit. Right, the last network bit in the subnet mask of 255.255.224 was in the third octet, and the positional value was a 32. Okay, now let's look at this one, a /28. We want to see where is it. So we look for the network bit, the very last network bit in the subnet mask. It's in the fourth octet, all right? And there it is, and its positional value was in the 16. So positional value is what we learned in week 1 or week 2, right? Just 1, 2, 4, 8, 16, 32, 64, 128. Remember that positional value starts over in every octet. Positional value starts over every octet. Every octet has its own positional value. Okay, so let's do a couple more. Let's do a /9. That'll be nice and easy. So we know that means we have 9 bits turned on. There's 8. And there's the 9th bit turned on. Everything else That's turned off. So here are all of my network bits. Here are all of my host bits. Now what do we know about this? This is a bunch of host bits. This is going to be a giant network, right? 8, 16, 17, 18, 19, 20, 21, 22, 23. So this is 2 to the 23rd hosts. I would definitely have to have a calculator to do that. Let's see. Calculator, so I'm going to do 2 raised to the power of 23. So what is that? 8 million. So it's 8 million. So it equals 8,388,608 minus 2, right? So it's a lot. It's a lot. But what is the magic number? My magic number, or my subnetwork increment, is going to be 128 in the second octet. Okay. Let's see, host bits, giant network, right? Giant network bits. Let's do another one. How about if we do, let's go ahead and do that /16. /16. So we've got 2 to the 16th is going to be our number of hosts, right? Okay, so here are all of my host bits. Here are my network bits. Okay, so I know that my host, it would equal 2 to the 16th minus 2. That would be the total number of usable hosts. What would my subnetwork increment be, or my magic number? Well, I look for my last subnet mask bit right there. It's in octet 2. And there it is. I'm going to have a magic number of 1, or a subnetwork increment of 1. We'll do 2 more, and then we'll call it. Okay, let's do 255, 255. How about 252.0? So 255, 255, 252. There we go, 252. So what is this? This is a /16, 17, 18, 19, 20, 21, 22, a /22. Okay, so I've got my chart over here. Let's see, 32. So my total number of hosts, or total number of addresses, is 1024 minus 2. So I would have 1022 total usable hosts, right? Here are my hosts. Here are my networks. I've got a /22. And what's my subnetwork increment or my magic number? It's right here. It's a 4 in octet 3. Okay. So you see why I love this chart. Let's do another one. This will be our last one. How about a 255, 255, 255, 192, 11111. I think you get the drill here. I think we're getting good at doing subnet masks. So here's all my network bits, right? The rest are host bits. How many host bits do I have? 1, 2, 3, 4, 5, 6. So I know I could do the math. 2 to the 6th, right? So 2 to the 6th equals 64 minus 2. So I have 62 usable addresses. Okay, all right. I've got a /26. That is what my slash notation would be. Now what's my magic number or my subnetwork increment? I look for where my last subnet bit is. It is in the 4th octet, right? And it is in the bit position of 64. So my subnetwork increment is 64, right? Again, I just want you practicing this stuff. I know that right now it doesn't completely make sense why we need to know this. It will start to make sense when we move through chapter 7 and 8. It will all come together.